Thank you all for showing up. My name is David Lindsay. I am going to be talking today about how to level up your dev skills with static analysis. So just a quick background on me. I originally have a math degree from university in one of the universities in the United States. After that, started doing quality assurance work, which quickly led into me doing security type of testing on large Java web applications. And in doing that kind of security testing as a QA person, quality assurance person, I originally was thinking I would transition from that into more of a developer career. However, as things turned out, I had a kind of a knack for doing the security testing and ended up getting a job at a security consulting company. So for most of the last 5, 6, 7 years, I've done security consulting, penetration testing, security research. I've talked at a handful of security conferences about different things. Nowadays, I work as kind of a security evangelist for a company called Coverity. We were acquired last year by a much larger company called Synopsys, which I'm guessing none of you have ever heard of, which is fine. So Coverity, we focus on doing static analysis testing. Together with Synopsys, we've also been acquiring some other companies as well to kind of expand what we do in the security space and software space. But the talk isn't really about that. I want to focus on static analysis kind of from a very neutral point of view, if you can trust me to not be too biased here. So the focus here isn't just on tools that you should use or whatnot, but really on how developers can really up their game in terms of what type of work they do. And since I have a security background, I'm going to focus on that. And a lot of, that's for obvious reasons. A lot of static analysis testing is very helpful at finding security issues, though you can find certainly other types of issues as well. So this is kind of a very high-level agenda of what I'll be talking about, just trying to keep it nice and simple. So to begin with, in terms of how developers can be doing things better, well, first I want to just talk about a few of the common ways developers fail at things. And again, don't want to be too pessimistic about developers. I'm sure you guys all do a great job. But there's a lot of things that developers do wrong or they could do better. And so, and I'm not going to cover all of them. I just want to highlight a few different things. So first, is developers for various reasons, often end up, writing inefficient code. If the code I've written, I'm sure every single line of code I've ever written in my life could be classified as inefficient code in various ways. So it's not necessarily like it's a very common thing. I'm sure a lot of code that people write is very efficient code as well. But this is one issue, and we have tools out there that help us with this type of thing. There's a lot of profiling tools that will instrument our applications, will help us find where we have bottlenecks in our code and those kind of issues. Just kind of as a quick survey, raise your hand if you've used such a profiling tool. Okay, so definitely the majority of people are raising their hands. And we even have several vendors here that have such tools that help with profiling. We have, there's open source tools that can help as well. So by all means, there's lots of, good things that you can use out there to help with these kind of problems. But just to be clear, these are not the kinds of issues that I'm going to be focusing on. Bottlenecks in your code and things like that are generally not things that you would use a static analysis tool for. Another common problem is just meeting delivery deadlines. I think that's probably the most canonical problem I've experienced in terms of software development projects. So again, nothing too particular I want to say here, just that, yeah, it's an issue. But what I do want to focus more on are the kinds of issues that show up in your code when it has, when there's just actual bugs in the code. So, writing, buggy code is hopefully not anything that we, are too ashamed about. I mean, it's again, like, sometimes we have inefficient code, sometimes we have code that just doesn't work right. And there's a lot of things that we can use to help us identify these issues. Like compilers will often tell us about certain, if our code doesn't compile, clearly there's a bug that needs fixed, right? But there's a lot of different kinds of bugs that can slip past those kind of checks. And even if you enable like different compiler checks and things, there's still a wide range of issues that can creep into your code still. And especially in the security world, where a lot of the security types of issues that show up are the sorts of things that are not easily, detected by your code, because it often ends up that your code, when there's a security issue, it's because your code is doing more than it should, rather than not doing enough. It's really easy to write unit tests and find, do different checks for things to verify that the code is doing enough. But it's hard to, understand, and it's hard to, flush out those areas where the code does more than it should. We'll talk a little bit more about that in a minute. So this is definitely the class of issues and defects that I want to focus on. So there's different nomenclature that people use in talking about bugs and defects. Sometimes people refer to flaws, is meaning something separate from bugs. Flaws being more like architectural type issues. Bugs being more like there's some line of code wrong in your code. I'm not going to worry too much about such distinctions, but if you care, I'm going to focus more on the bugs kind and less on the architecture type of issues. Okay, so talked a little bit about some of these problems that we all have, and definitely want to focus a lot on some of the things that we can do to not suck quite so much when we are writing code. So the first thing I want to point out is just that it helps if we can all have a little bit of humility and acknowledge that we're not experts at everything. So hopefully that's not too shocking for anyone, or I'm not blowing anyone's ego, but there's a lot of things that you guys are good at. Definitely you're experts at understanding your code, different programming languages. I can't hold a candle to your skills in that regard. But there's certain things that you just aren't good at, and security usually is one of them. So so not to belabor the point too much, but just wanted to do another quick survey here. So just as a quick raise of hand, keep your hands up as I go through some of these questions, but I'm just curious, how many people are familiar with cross-site request forgery? Is that a vulnerability class? Okay, so good. So most people are raising their hand. So what about the confused deputy problem? So keep your hands up if you're still something that you're familiar with. So there's a couple hands still up. Most have gone down by now. Okay. So what about cross-site scripting? So, okay, a bunch more hands go back up. Okay. What about DOM cross-site scripting? Familiar with that? So a few hands went down, a few still up. What protections are built into the client-side JavaScript to enforce the same origin policy?
Kind of one further, so we understand your question better.
Oh, I'm sorry, what was that?
You're faster talking than...
Oh, I'm looking at the wrong, I got two slides here, thank you. I'm looking at the wrong slide, so I'm looking at the one ahead, sorry. I had it off by one error, thanks. Okay, here we go. What protections are built into client-side JavaScript to enforce the same origin policy? Is that something you guys are familiar with? So there actually are quite a few things in it, built in. It shows up in lots of different ways. I don't want to get into the details here, but to understand, browser security and web application security, these are all things, areas that are very, very, that you need to be brushed up on. Right, next one. Which HTTP headers can make exploiting cross-site scripting more difficult? Is that something you guys are familiar with? Yeah, so there's a few hands up. Just kind of as a side note, I'm curious how many people are familiar with the specific cross-site scripting filters that certain browsers are building in these days, or for the last several years now. Yeah, so there's still a few, okay. So if any of you guys work for Firefox, I'd like to talk to you. I'm curious why Firefox still hasn't done that. Okay. So the last one, how to properly mitigate for cross-site scripting using output sanitization. This shouldn't be, hopefully, too difficult. So just out of curiosity then, who has actually written a sanitizer for something like cross-site scripting? About the same people who've been raising their hands before. So again, this is not a very common thing. And that's not necessarily a bad thing. There's lots of frameworks that, or libraries that you can use that maybe do this for you, so it's not an issue. But it's the sort of thing that hopefully developers keep in mind, or if they're not, that they're using tools that will help them identify these kind of issues. So I talked a little bit about cross-site scripting just now, but I didn't really explain what it is. And so for the benefit of everybody in the audience, I wanted to kind of go through just a simple detail, because I'll kind of use this as an example later on in my presentation. So I'm using just a simple JSP line here. So usually the canonical Hello World app is just print a static string. The next, if you're beginning to learn Java or any language, the next step is usually to output something that's customized using a variable. So this is like that second iteration of Hello World, where you're outputting a name that's being submitted to, as a GET request parameter. okay with me so far? Okay, so the normal case is that I would, for example, go to a URL like this where I put my name, David, and then when the JSP gets this, it will do the substitution. It will do the request.get parameter, substitute it, and output the string hello David, right? Very straightforward. So issues with excuse me, cross-site scripting issues show up when a user like me submits something like this. So instead of just putting my name, David, I now put some script tags after that. So when the JSP does the substitution and puts in my name, it now gets the full string, David, script alert 0, close script. And when that gets put back into an HTML page, you can guess what would happen, right? The script will execute. And so this is a canonical example of cross-site scripting. Why is it bad to have alerts show up on your screen? Well, alerts aren't bad, but it's just a proof of concept to show that I am able to execute JavaScript. And what's to kind of think about how this might be exploited, just so you can understand the severity. Instead of doing an alert 0, I might do something like access your cookies using document.cookie. And what can I do with your cookie? Well, I can add it to a string and then send that to a third-party website that I control. So if I can entice some victim user into clicking on this malicious URL that I concocted, then when they click and load that string, all of this will happen automatically, where the string substitution will happen in the JSP, the script will then be executed on the page when the HTML loads, and my JavaScript will now execute, take this victim user's cookie, send it to my web server, and now I, as the attacker, have access to their cookies. I can now go put that into my browser, cookie jar, log in as that user effectively, and now have full access to their account. So that's just kind of one example. There's lots of other things you could do with cross-site scripting, but that's kind of the generic, the most common example that people use. And there actually have been real-world attacks like that, where that's happened. Like 4 or 5 years ago, for example, the Apache Foundation was kind of hit with a nasty targeted attack, and it all started with exactly this kind of a cross-site scripting error. So I talked a little bit about how cross-site scripting works and why it's bad, or kind of what the exploits are. So let's talk a little bit about prevention, because that's what developers really should care about, right? So in terms of prevention, so I'm going to give a few examples of things, and some of them might seem kind of ludicrous, but I present them only because these are all actual responses I've gotten back from developers, when I've reported a cross-site scripting issue, and these are things that they have actually done to try to mitigate them. So the first one is to block the word alert. This is probably the most ridiculous one I've seen of all, but it actually does happen. Even there's some web application firewalls that think that blocking alert will be useful, but so obviously this does not help, because I can, even if it doesn't even stop me from executing the alert command in JavaScript, because all I have to do is use window.alert. But then instead of using dot notation in JavaScript, I can do window and then use the array notation and then put in alert in the array. And when I do that, alert is a string, right? And when it's a string, then I can mess it up however I want. I can do various character substitutions. I can break it up into 2 strings. So just doing a simple pattern matching for the word alert clearly is not going to get me anywhere. I can still, pretty much directly execute the alert or any other JavaScript function that I want. Next, blocking the HTML tag angle bracket script. So does this seem more useful? Yeah? No? No. So how can I get around this? So if a developer, blocks, the script tag. Make sure I have the right one here. So if they block the script tag, then I can't directly execute script, but what I might be able to do is just use another way that browsers can execute JavaScript. Anybody know off the top of their head another method that will allow a browser to execute JavaScript? You in the back? What was that? On click? Yeah, on click. So that's an example of an attribute that a lot of HTML tags support, and these are called event handlers. So one of the ones I like to use, because it fires automatically instead of requiring user interaction to click, is on error. So if an image tag has references an image and that image fails to load properly, then the on error event handler fires automatically. And if you're injecting an image tag, you can obviously put in a broken link, right, as the source for the image. And so then I can guarantee that that on error will event handler will fire, and then I can put in whatever JavaScript I want as the attribute there. So, okay, so let's say that on click and on error are blocked, for example. Well, obviously there's other kinds of event handlers that work as well, right? And most of them all start on star, maybe all of them do, but there's even a few special cases, especially in Internet Explorer and older versions of browsers, where you can also achieve this kind of get HTML tags that will execute JavaScript that don't involve the event handlers directly. So if you know about all of those, and you block all these outdated artifacts from IE that should have never existed in the first place, then maybe you can block all these event handlers. But even then, you have to be aware that, like with HTML5, a lot of new event handlers have come out, and so even if you try to just kind of blacklist all these different event handlers, you're not necessarily future-proof, because as new event handlers get added in, you're going to have to keep updating your blacklisting filters. But even then, is not always enough. So make sure I'm on the right side here. So another case I've seen is where simply all of alphabetical characters, everything between A and Z was blocked. And in this particular case, I was not injecting directly into the inner HTML like we were in this example, but I was actually injecting directly into a JavaScript string. So in that case, if I had a filter like this where all characters were blocked, would I still be able to achieve code execution? Anybody say yes? Do you have any examples that might work?
Unicode?
Unicode. So Unicode might work if, depending on how things are processed. I don't think this regular expression would normally match against Unicode, but then the question is, can Unicode characters be interpreted? Well, they can be interpreted as JavaScript, but can I do anything meaningful with them? Maybe. There's also sometimes character encoding issues where if the attacker can control the character type of the page, which sometimes happens, then they can maybe set it to something different that will allow different characters to get converted into the actual things like a val or alert. So those are good options to explore. Just kind of a way to avoid some of that is to just restrict yourself to certain characters. So has anybody heard of a JSfuck or a brainfuck, kind of an esoteric programming language? So brainfuck is this esoteric language where they wanted to create something very small, minimal. So there's only 8 characters that are allowed in brainfuck, and then you can write kind of a really simple custom compiler for this language. Well, JSfuck is kind of like that. Actually, I think I have time. I'm going to see if I can load this page real quick. In fact, I got it here. Okay, so JSfuck is kind of the same idea, but it's using pure JavaScript, and you don't have to have a custom compiler written to compile it. It's just using the standard JavaScript compiler, which is an important distinction here. So using just any standard compiler built into any of the browsers, and using just these 6 characters, the open close parentheses, the open close brackets, and the plus an exclamation point. Using just those 6, I can execute arbitrary JavaScript code. And as a kind of proof, I didn't create this site, but somebody created this just as a proof of concept of how that works. So if I wanted to execute like alert 0, click in code, and then this is the output that's generated. So this here is actually straight up pure JavaScript that will execute. And if you don't believe me, click run this, and there you go. There's my alert. So the moral of the story here is that, going back to my slides, play from current. Okay, so here is that even in situations where I can't inject hardly any normal characters, just a few random characters like the parentheses. Even then, I can still have arbitrary code execution for JavaScript in certain situations, which I think is pretty cool. So I kind of talked about it, a lot of the bad ways to do it. Anybody want to suggest a better way you might actually want to prevent cross-site scripting? So whitelisting, yeah, that's a great approach. So, for example, a lot of cases, what kind of data is to be expected, and so if you are expecting only, let's say numerical characters, like like if it's part of a phone number or part of an ID field, and if you know it's just numbers or maybe just text values, you can restrict it just to a whitelist of a minimum number of characters as possible, and then just validate that the input matches that. So this whitelisting approach is much, much better. There's other things that you can do as well in terms of output sanitization. If you to do it well, you need to understand exactly what your output context is, whether the output is going into JavaScript versus an HTML tag versus inner HTML. All these, you require different kind of encodings and escaping of characters. And so, but definitely both are good approaches. Input, whitelist filtering on the input or proper output sanitization on the output. Okay, so all that was kind of emphasized that security is hard to get right, and developers oftentimes make mistakes. But the good side here is that you are experts at your own code, right? And you're and experts at understanding your business environment and what kind of data needs to be protected, and all of that is very valuable information that you can use to your advantage still. And so I want to talk about some specific techniques that you can use to help you find bugs in your code still. And I'm going to talk about these just in a very generic way, because when I talk about these are all things that you should be doing, I'm talking about you collectively as like your organization. Some of them are more suited for developers. Some of these testing techniques are more suited for others. But let's kind of go through them real quick in detail. So security training is a really obvious one, right? That's partly why I think you're all here at this conference, well, to get developer training. But security specifically, I think, is very helpful for developers as well. So hopefully that's why you're here in this talk. So by all means, that's a great thing to do. I'm not going to talk too much about it, but just wanted to highlight that certainly it's there's a lot of value that can be gained by getting specific security knowledge, and that will stick with you for the rest of your life, hopefully. So definitely look into some courses that you can get. Let's not cross them out yet. So next is manual code review. Just out of curiosity, how many people have done actual code review in the last year? Most people? Okay. And was it on your own code or somebody else's code? Raise your hand if it's your own code. Okay, and raise your hand now if it's somebody else's code. Okay, so again, a large number of people are doing this, which is great. Out of curiosity, any of you that have done a code review recently, did you find any security issues? Okay, much fewer hands. Nice to see that a few are being raised still. Okay, good. So that's certainly one technique that works. One of the downsides to doing code review, not to be too negative on it, but is that it's hard to review other people's code, right? You're not familiar with how it's written, and you spend a lot of time just understanding why they named the stupid variable the way they did and things like that. And so there's just this learning curve to kind of get used to their styles and such, which is fine. It's just kind of one of the necessary things you need to do, but it does make it a little bit harder. But you also have this problem of reviewing your own code, and that you are inherently biased to how you interpret it, because you wrote it. It's hard to sometimes see obvious things in your own code. I like to use an analogy of like with my wife, who happens to be an author. She likes to write poems and short stories, and she'll work on some piece, like say it's just like a short one-page story, but she'll work on this for weeks at a time, and then finally get into a good state and where she's really happy with it. And, it's a brilliant piece of work. She'll have me review it, and I'll go through, and there's like obvious like typos and things in it, and it's because she's just so familiar with it, like she sees it how she wants to see it rather than how she intended it to be. And so even when she reads it, like she'll skip over words that are transposed or double words, things like that. So it's the same when we're programming. We're so familiar with our code that sometimes we just see it how we thought it should be rather than how it is. So again, the manual code review can that's one of the gotchas when you're doing manual code review as well. Kind of akin to that, it's pretty much the same thing, but using kind of some sort of grep tool to help you with a manual code review. I mentioned this just one of the very first times I did a code review when I became a security consultant. I was working for a antivirus company, and they had a new product that was coming out, which was like a huge suite. So it included the client-side code, which in and of itself was a huge beast. Millions of lines of code, lots of different components interact. The Windows operating system at a low level. had some web components to check back into the server to see if there needed to be updates or needed to download new virus definitions. There's a lot of other things they'd set up on the website for users to get information about what might be malicious websites that they're visiting. There's browser plugins. And so it was me and two of my coworkers, the three of us, had 2 weeks to do this full test on this whole system, which is definitely not enough time. I'm sure you guys are familiar with that problem. And so in going through this, we asked if we could get access to the code to do code review, because that would make it a lot easier to test a lot of the components, and we could do a much more thorough job than if we're just blindly doing penetration testing on some of the components. And so the point of contact was able to get us access to a few 100,000 lines of code for the client component. It wasn't everything, but we'll take what we can get, right? So we were reviewing some of this code, and this part happened to be written in C that we're looking at. And so because we had so many different components to look at, I had about 4 hours that I could allocate to looking at about 200, 300 lines of code. And clearly that's not enough time to give it justice, right? So I was thinking to myself, okay, how am I going to do this most effectively? I want to, do a good job, but so I need to quickly kind of focus in on areas that are going to be of interest, right? So if most of you have done a code review, so how would you what kind of things would you flag to help you quickly zone in on different code pieces? Yeah. So input, so yeah, where you have untrusted data coming in, perhaps that's definitely a good starting point. So just a few other things that you might want to look for. Maybe whenever there's crypto being used, right? That's oftentimes crypto is misused. Salts aren't properly generated, or initialization vectors aren't properly used or generated. Bad sources of randomness. These are all things that are pretty common, and it's pretty easy to grep through the code and find these sorts of things. Another thing is where crypto should be used, but it isn't. That might be a little bit harder to find, but you can also look for things like that. You can also look for other kinds of security controls that should be in the code. Things that you'd expect, like if sensitive operations are happening, is there proper authorization checks in place and things like that. So those are all things that if you are kind of familiar with the code, you can maybe grep through and find. In doing this particular code review, one of the things I thought of, somebody had mentioned to me about how, buffer overflows are an issue for C code, and somebody had mentioned, how oftentimes a developer will, allocate copy an arbitrary length string or arbitrary length data structure to a fixed length buffer, and that's the sort of situation that can lead to a buffer overflow. So I thought, oh well, maybe if I could identify, fixed length buffers as a starting point, rather than just searching for like mem copies and string copies. Which I did that as well. But so I started looking for just powers of 2, like 32, 64, 128, all the way up to like 32656 or whatever. And so powers of 2 and also powers of 2 minus 1, because you got to account for the null character, right? So searching for these just fixed numbers, and I had it a couple dozen hits, and one of them was in a file called networkinput.c. I'm like, oh, that's interesting. So I actually spent like 20, 30 minutes looking at that and realized it was right there in front of me, a buffer overflow. They had a fixed length buffer of 128 characters, and it was reading in something from the network, and then a few lines down, like 20 lines down, it was doing the string copy. And I'm like, oh wow. So when I reported this to our contact person who came in, at the end of the day to check in on us, I mentioned how I found this, and he's like, oh, that's interesting. We ran a static analysis tool against this just last week, and it didn't pick this up. I'm like, okay. And so I asked him which one he used, and fortunately he didn't use Coverity. He used somebody else. So, tools like this are doing, techniques like this, like, manual code review, grepping through the code to find things. They're definitely great things. In the interest of time, I'm going to skip through some of them. Unit tests are obviously helpful, but again, unit tests aren't really great at capturing, like security types of defects. Dynamic analysis. So this is more like, where you set up a staging environment and you can test your applications there. This is normally, quality assurance testers oftentimes will focus more on this kind of area. There's automated tools that you can run against a running staging environment that will find, security vulnerabilities and, try to crash the application, things like that. Having external consultants come in and actually do, pretend like they're the bad guys and do pen testing is very useful. One of the downsides to some of these like dynamic and penetration testing techniques is that they're not things that you can really incorporate into the development lifecycle very well. It certainly can be done like, maybe once per release or maybe, every time you update your staging server. But in terms of things that developers can do, these are usually kind of external to your world, and so they're not necessarily things that you would spend a lot of time on. So, and the same with the things at the very end, like an architect for your application is probably going to focus on doing things like architectural analysis or threat modeling. So if you kind of limit things that the developers can focus on that will give them the most bang for their buck, there's really these two that that really come out stand apart from the rest, and that's doing security training and the static analysis. So I mentioned security training earlier. For the rest of the talk, I want to kind of just focus on what exactly the static analysis is. So we'll leave web application firewalls off the list. They shouldn't even really belong there. Okay, so all this has kind of been a long introduction to kind of get to why static analysis is something that developers should care about. So the next question I want to answer is what the hell is static analysis? So the basic idea is really simple. We take as input your code, it goes through our machine, our analysis engine, and we output a nice simple list of issues in your code. And ideally we'd be a little bit more specific than just line number, but you get the point, right? So another way of doing the same diagram is that we are this. We take your nice pretty code and output something that's a little bit more, we make it look a lot messier, so to speak. And then we kind of put a bow on it to try to make it look nice. That's why I had to use this image, just because of the parsley there or whatever. I just thought it was funny that they're trying to make it look pretty. But that's exactly what we do. We tell you all the bad things about what's going on in your code, and we try to put a pretty bow on it. So there's a lot of theory and research that goes into how a static analysis engine works, and I don't want to get into all the details now. But if you're interested, this is a good starting point. It's kind of a graduate level type of textbook, and helps if you have a little bit of a math background. If you want to talk to me afterwards about some of the inner workings of the static analysis engine, I'd love to chat. I know there's some people I've already talked to here at the conference that have done years and years of research in static analysis, which is great. You probably know a lot more than I do, but it's more than I have time to get into now. So one of the things that I would like to cover, though, is what's the difference between a good static analysis tool and a bad static analysis tool. So just like developers can have their good days, bad days, or there can be good developers, bad developers. It's the same with security pen testers. It's good with it's the same with static analysis tools. They're not all created equal. So the first most obvious thing that a tool can get wrong is that it just misses the obvious things. So if there's defects in your code, you want it to pick them out, right? And if they're right there in front of your face and the tool doesn't get them, there's nothing more frustrating than that. That's the whole point of you running the tool, right? So sadly, there are a lot of tools out there that fall into this category. Now, I'm going to mention one of the open source tools here, Find Bugs. And it's not because I'm picking on them. I actually do encourage everyone to use Find Bugs if you're not right now. It's a great tool. Just know that some of the limitations in that it covers a few areas really well, but there's a lot of categories of types of issues that it just doesn't cover at all. And so it's definitely better than not using any sort of static analysis tool. But in terms of the coverage that you get, both in terms of how deep the checkers are and how broad they are, in terms, the number of different types of classes of vulnerabilities or defects that it can detect, it's limited in scope in both ways. So again, I'm not really dissing on Find Bugs. I want everybody here to be using it if you're not, but just know that there's a lot more that you can be getting. It's just kind of like step one. You should be, you should definitely get there and then focus on getting to steps 2 and 3 and use, find, tools out there that can help you with some of these other categories as well. Okay, so the other end of the spectrum, instead of not finding the obvious things in front of you, is to have a tool that flags everything, or just flags way too much. And it's sad, but there's actually a lot of tools that fall into this category as well. I'm not going to mention any names, but a lot of especially in the security world, tools don't want to fall into that first category of missing obvious things, so they err on the side of just flagging way too many things, and you end up with like this information overload where either there's a lot of findings that are just low value and not important to you, or even worse, the findings that it's reporting are just completely wrong. And in a lot of situations, that's not necessarily a bad thing. Like as I was a security consultant for many years, I would use these kind of tools, quite regularly on different projects. And the reason why is because even with all these, extra, garbage that it was throwing at me, that was still much better than, the alternatives, like, doing a manual code review. It still would help me to zero in and focus on certain parts of the code. And so I would, spend my time actually going through and triaging, the different alleged defects and figure out which ones are real and which ones weren't. And just, it's, not unusual to have tools that report 95% false positives. So that means that like 1 out of every 20 issues that it's reporting is something that is actually a real issue. I don't know about you, but that's, as a developer, that's not something that I would be very happy with. If I have to, like if you had QA testers that were submitting bug reports into your bug tracking system, and 19 out of every 20 issues were bad issues, I think that person would be fired or moved pretty quick, right? So it's the same with your, certain tools that are out there. If they're giving you garbage, it's just you're better off not using it at all. So, a good, static analysis engine will not have this problem. It will, especially if it's developer oriented, it will have, a false positive range more like, in the 15 to 20% range, something like that, where maybe 1 out of 5, 1 out of 6 issues is something that's not real. But that's about the threshold we've, determined over time that the developers are willing to, tolerate. So there's never going to be a perfect, tool that will, be 100% accurate in detecting, the right things and not detect the wrong things. There's always going to be some, there always needs to be some room for error. But just, if you can keep the false positive rates down below like 15 to 20%, I think you're in a pretty good situation. So what are some other things that you can do, that a static analysis tool can do to not suck quite so much? So we already kind of talked about the first two in terms of identifying defects accurately and not reporting on false issues. A couple other things. So a good tool will help you quickly triage issues. So ideally, if it's reporting some defect in a particular line of code, well, in reality, most defects aren't just on a single line, but require some understanding of the local context, or maybe there's a variable that's in one class that gets then used over in this other class, and you need to understand those types of connections. So a good tool will kind of act like an IDE in some ways in terms of helping you quickly navigate around your code, understand where variables are initialized, and so forth. So that's one thing to look for. Another is the kind of remediation device that you get out. Like, is it just a generic remediation device that says, to fix your cross-site scripting, you need to sanitize your inputs? Like, okay, what does that mean? So, the more specific and customized to your code that you can get remediation device, that's obviously more helpful. And there's no reason that a good static analysis tool can't do that. If it's actually looking at your code, it should be able to understand those kind of nuances. So we don't have a lot of time, but just real quick, I'm going to go to this other website. So this is the OWASP Web Application Security Consortium. So they have a nice document here on the web. It's actually not that long, just talking about specific things to look for if you're evaluating, like there's an evaluation criteria for static analysis technologies. So it's exactly the sorts of things that you all should be looking for in terms of what makes a good tool. So I'll just highlight some of the main topics that are covered here. So, like one is, how the tool is deployed. Is it, desktop? Is it run as software as a service? Does it integrate into your build server, into your IDE? What kind of support there is? What kind of, runtime dependencies there are? What kind of technologies are supported? What languages are supported? Obviously, if you're programming in Java and JavaScript, you'd want those to be covered, for example. There's also, the different kind of technologies. Does it also, look at your XML files? Does it look at your config files for your struts frameworks, for example? There's how do you actually, interact with the tool? Is it just all like a GUI wizard where you click a button and everything's done, or are you able to, build it, integrate it into your Ant scripts? What kind of IDE integration? Oh, a good one is, customization. What type of, so good tools will understand a wide range of frameworks, but especially like in the Java world, there's a lot of frameworks out there that can be used, and no tool is going to understand every single framework. So it's really good to be able to to inform your tool like this about some of the way your frameworks behave. That will allow it to do better, understand the data flow through your application better and so forth. So that's definitely one thing you want to look out for. What kind of customization is available and how powerful it is. And then also, it's just the actual capabilities in terms of what types of defects does it find. So I'll talk a little about these later, but I just want to highlight that there is this nice list here on the website of different things different classes of vulnerabilities that a static analysis tool can find. So you can go ahead. There's a few more things here on the page, but I'll leave it at that in the interest of time. So back to my slides. Okay, so I talked a little bit already just now about some of the defects that a tool can find, but I wanted to go into a little bit more detail just to make sure people understand exactly what types of flaws what types of bugs you can expect a static analysis tool to find. So one of the big main categories is called data flow, and this isn't just one type of vulnerability. There's lots of different kinds that fall into this category, but they all kind of follow the same pattern. And so we kind of talked through the cross-site scripting example earlier. That's an example of data flow. But just to reiterate, so you have untrusted data that comes into your application through like a request.get parameter, for example, or maybe through web services, or cookies that the user submit. There's lots of different ways that untrusted data can get in. And also, keep in mind that what's considered internal versus external. A lot of that depends on what type of application you have. Like if you are working on a back-end system that interacts with some front-end system, you might choose to just distrust anything coming in from the outside, for example. Or maybe if you have an application that reads from a database, but other applications write to the same fields in that database as your application, then maybe you don't trust that data coming in from these other applications, in which case you'd want to distrust data coming from the database, for example. Or if you are a client-side application, you maybe want to distrust things like environment variables, things that a malicious user could control. Whereas on a server-side application, maybe those would be less of a concern. So anyways, the untrusted data can refer to a lot of things, but it's just anything that you want to define as being external. And so ideally, like in a static analysis tool, those would have some sensible defaults, but also be something that's customizable, right? So once you have the untrusted data coming in, it comes in through like request.get parameter, but then it's going to be assigned to a variable. That variable is going to be part of a class. It's going to be maybe through reflection assigned to some other variable, and that just gets passed around to the code. And then eventually, at some point, that untrusted data ends up somewhere, and that's what we call the sink of the data flow. The sink could be lots of different things as well. So it could just be outputted back to the user as part of an HTML page. It could be a database write. It could be a write to a file. It could be, some sort of concatenation to a regular expression. It could be, part of an email that gets sent out. LDAP servers, an LDAP query string. There's lots of different ways, places where untrusted data ends up, and all of these can lead to different vulnerability classes. And so the namings for a lot of these isn't too surprising. We usually just kind of refer to them based upon what the output context is. So if it's back to an HTML page, then you have cross-site scripting. If that data flow sink is a SQL query, then you have SQL injection and so forth. So. So those are definitely a neat, a very interesting class of vulnerabilities, because there's a lot of really bad things here. Like SQL injection, for example, what happens if a user can actually modify a SQL statement? Well, if they're just blindly adding characters in, they can maybe cause a malformed SQL statement. But if an attacker is intelligent and able to carefully craft that SQL statement to do things, they can probably figure out what table names are used in your database. And once they know the table names, they can look for things like like user credentials, or some place where passwords are stored in your database. And then once they know that, then they can pull out the passwords. All this just using SQL injection. And so, databases are where where companies often store a lot of their really sensitive data. So this obviously can lead to a lot of really bad things, for example. But a lot of these others as well. Obviously, code injection. If an attacker is able to inject code to your and have it run on, like if it's a web application, able to have their code run on your server, that's a bad thing, right? Just out of curiosity, how many people have used struts before, or struts 2, let's say, struts 2? So maybe a third of the people in the room. It, for example, has a history over the last 5 years of having lots of OGNL code injection issues, which is exactly this kind of scenario. And so just wanted to point out, definitely keep up on the latest versions of that, especially any new ones that come out in the future. Stay updated. Okay, so another class of errors that I think is really neat, worth talking about, are copy-paste errors. And that's because there's actually not a lot of tools that look for these. But it's a really neat that they can even be found using static analysis techniques. So I have here, kind of a common example of how this occurs. So if a developer has, some code here, they want to reuse that code later. Oftentimes, it's easier to cut and paste the code, right? But oftentimes, they'll need to substitute variable names. So in this context down here, they maybe need to, instead of using returns not equal no, they want to use locals not equal no, right? And so, if you look at this, you can see that they substituted, some variable names in certain cases. Take a minute and look at this. Raise your hand if you think you can see which variable was missed on the bottom half here. So a few people, especially those at the front, that can see it easy. So a few people have an idea, right? So if you look here at the very last line, it does this assignment of the returns variable. And returns is the variable used at the very beginning in the if statement. So you can see down here, the variable used in the if statement is locals now. And so probably at the end, they meant to have locals be the variable assigned, right? And obviously the developer missed that. That's the sort of thing that I love that a static analysis tool can find, because it's so difficult to spot using manual code review, for example. 5 minutes? Thank you. So this is definitely one of the really cool things that a static analysis will pick up on. And just kind of reiterate the point. Here's another example. So again, 2 different if statements: if, else, if, else, and then it's repeated again in the lower half of the screen. And so again, there's some variable that's been substituted. Raise your hand if you think you've picked it out. So one person so far, a few people, yeah. So they're not obvious, right? They take a minute, and so you can look at code like this, for an hour and not pick it out. Or if you're doing a code review, I doubt very many of us would spend so much time on just simple little bit of code right here, and spend long enough to actually pick out the missed variable here. And it's possible that for example, unit testing might capture this kind of issue, but even, depending on what those variables are at runtime, it might not even, trigger a unit test. So for those wondering, it's the right in the middle there. Default value was not properly substituted. Okay, so that's definitely one of the cool classes. There's a lot of others. I'm not going to have time to go through all of them. I only have a few minutes left. But another interesting one, for example, is just where you have null dereferences. And one of the ways a static analysis tool will look for this kind of issue is look for where a particular variable, such as x here, is being checked against null. And if the developer is going out of their way to check that a variable isn't null, that's a good indication that it's at least theoretical that it could be null in some situations, right? So we use that kind of as a assumption that in some cases this variable might be null, especially if we see it multiple times, and then being checked against null. But then in some instance it's not, or there's some code execution path where it can reach some place where it's being referenced without that null check. Then you have a good situation for null dereference. In this case it's really obvious, but imagine trying to spot something like this when these are in different files, or there's 200 lines of code between the two of these statements. That's when it gets really hard to pick out these types of things. So just I'm out of time basically, but a lot of other different classes of issues. So I just wanted to kind of provide a quick list here of all these different things. So at the end of the day, I guess the main point of my talk here is that we all write buggy code. It's not anything anybody should feel bad about. Just like when I write a technical report, I have to have somebody like an editor or have some coworker review it to make sure that we get the bugs out. Make sure the grammar's right and all that. It's the same with our code. It should just be par for the course that we are using such tools on a daily basis to help us catch these kind of things that just kind of slip through the cracks. And I hate to use like fear, uncertainty, and doubt as like a motivation tactic, but it's worth pointing out that there are bad things that happen sometimes when you have buggy code. I mentioned earlier that Apache.org was hit by a cross-site scripting attack, and that was just kind of like the first step of the attack. After that, they were able to get access to one of the accounts, which led to getting access to one of the servers, which led to getting access to passwords in the database. It was this very, very involved, complicated attack, but it all started with just a simple application vulnerability. Another one that I wanted to highlight real quick is the Heartbleed vulnerability. So not Java code, but this one is just interesting because it's in highly critical code that's used by billions of users, and we actually know who the developer was who checked it in, and so he was interviewed about the code. So I feel I don't want to pick on the guy too much, but it's the sort of thing that any of us could have made. He just happened to be working on highly sensitive code, and something slipped through the cracks. So we definitely don't want to be that developer. Not that he did anything wrong, but let's try to stay out of the headlines, or if we are in the headlines, being there for the right reasons. So summary, be smart, use the right tools, to get the job done. And if you do so, you can really up your game skills and bring your dev skills to the next level. So that's it. Thank you. Any questions real quick? Feel free to step out, but yeah.
Good question. What tool for Java you would recommend straight away?
Coverity, of course. So I tried really hard not to pitch Coverity in the whole talk, so hopefully I didn't fail there. But so if you need to use an open source tool for Java, FindBugs is a great starting point, like I talked about. But there really aren't any open source tools out there that do a really deep, thorough job. If you do use FindBugs, there's a plugin that you can get called Find Security Bugs, and it's just you just drop it in the directory, and it automatically will add a whole new class of issues that it'll detect. So if you use FindBugs, I highly recommend you use that plugin as well. But even then, the coverage you're going to get is very shallow. Any other questions? Okay, thank you.